In this video, we're going to work on the first exercise on this worksheet, exercises on consumer and producer surplus. So you can read through the information if you have a copy of the worksheet. If not, we're going to scroll down here and begin the exercises. Reminder that you can always press pause, and in fact it's a really good idea to do so, to try the exercise first yourself before just watching the solution. So the exercise says find the consumer surplus and the producer surplus at equilibrium for each of the demand curve and supply curve pairs below. So we'll do question 1 in this video. We're told that the demand curve is 13 minus x squared and the supply curve is 4/3 x. So if we need to find the consumer and producer surpluses at equilibrium, then the very first thing that we need to do is find the point of equilibrium. And that point of equilibrium is going to be the point of intersection of the demand curve and the supply curve. So let's sketch what this looks like. So we'll put x on the axis where it usually goes, and x very often is referred to as Q, the quantity, and the other axis is the P axis, the price axis. So the functions are actually P is equal to D of x, and P is equal to S of x, the demand curve and the supply curve. So our demand curve is a downward facing parabola, so let's go ahead and sketch something that looks like that. The demand curve is decreasing. It is always decreasing, not always, very often decreasing. And we have the x-intercept at root 13 and the p-intercept at 13. The supply curve is increasing. It is increasing as very often the supply curve is. And so this is S of x, which is our 4/3 x, and this guy is our demand curve, which is 13 minus x squared. And so our point of equilibrium is going to be right there. And so we're asked to find these values at equilibrium. So we need to find that point. X sub q is the very typical notation for the quantity at equilibrium, and the price, P sub q, is the price at equilibrium. So let's find the point of intersection of these. So we're going to set the curves equal. So we'll set the supply curve, 4/3 x, equal to the demand curve, 13 minus x squared. This is a quadratic that we can solve, so we're going to bring everything over to one side. X squared plus 4/3 x minus 13 is equal to 0. If I multiply through to clear out the denominators, I'm going to get 3x squared plus 4x minus 39 is equal to 0. And we can try factoring this. And so we're going to need 3x and an x. The factors of 39 are 13 and 3. So let's try the 13 there and the 3 over there. And then we need to choose the sign since it's negative. And so I'm guessing that's going to be a plus and a negative. Let's do a quick calculation. We get 3x squared minus 9 plus 13 is plus 4x minus 39. There you go. That factors correctly. So that is giving us two solutions as far as the quadratic is concerned. X is minus 13 over 3, and x is equal to 3. So quite obviously, we're not talking about negative values here. So our x value in the point of equilibrium, so x sub q, this value here is 3. We need to find the price at equilibrium, so p sub q. We can plug it into either curves. Let's plug it into the supply curve because it is a little bit more straightforward. So 4/3 times 3 gives me a price at equilibrium of 4. So there's the point of equilibrium, the point 3, 4. And now we can go ahead and find the consumer surplus and the producer surplus. So let's start with the consumer surplus. Consumer surplus we know is an area. It's an area between the price, the equilibrium price, and the demand curve. So we're looking for that area there. And the consumer surplus formula, we can write that down, is the integral from 0 to whatever x value, so we're looking at the equilibrium x, of the demand curve minus the price that is set. So here it's the price at equilibrium, dx. Filling in the values that we know, then this is going to be the integral from 0 to 3. Our demand curve is 13 minus x squared minus the equilibrium price, which is 4 dx. Simplifying inside the integral, so 0 to 3, 13 minus 4 is 9 minus x squared dx. So we need an antiderivative, 9x minus 1/3 x cubed. That's going to be evaluated from 0 to 3. So evaluating at the top, 9 times 3 is 27, minus 1/3 of 3 cubed. 3 cubed is also 27, minus 0, so that's going to be all just 0. So 27 minus 27 over 3 is 9. 27 minus 9 is 18, and so that's the answer. The answer is 18, but then 18 what? What does that mean? 18, this is a price. This is the benefit to consumers from paying a lower price. So typically this would be in dollars. We're not given units for these things, dollars or in maybe thousands of dollars, right? Thousands of dollars or millions of dollars. Who knows, right? We're not told, but it is in some kind of dollar amount, the consumer and the producer surplus. Okay, next then we're being asked also to find the producer surplus. The producer surplus can also be interpreted as an area of here. This region, which is the region below the equilibrium price and above the supply curve. So that region in green is the producer surplus, and that formula is the integral from 0 to xq, the equilibrium price. This time we're doing the equilibrium price minus the supply curve, dx. So filling in those values that we have, the integral from 0 to 3, the supply curve, the equilibrium price is 4 minus the supply curve, which is 4/3 x dx. And I could do this entirely by integrating again, but I'm going to recognize that this is a lovely triangle, and I'm going to use just geometry, 1/2 the base times the height gives me the area of that region. So the base is going to be this distance right here, and so my base is 3. My height is this distance right here, and I know my height is 4. So 1/2 of 3 times 4 is going to be 6. And again, dollars, thousands of dollars, dollars or something, right? Dollars, or who knows what the units are for these things if you're not told.